The M134 minigun is a 7.62 x 51 mm NATO, 6-barrel rotary machine gun with a high rate of fire, 2,000 to 6,000 rounds per minute, which can also fire at a high sustained rate. It features Gatling-style rotating barrels with an external power source, normally an electric motor. The mini in the name is in comparison to larger caliber designs that use a rotary barrel design, such as General Electric's earlier 20mm M61 Vulcan, and gun for the use of rifle caliber bullets as opposed to autocannon shells. The minigun is used by several branches of the U.S. military. Versions are designated M134 and XM196 by the United States Army, and GAU-2/A and GAU-17/A by the U.S. Air Force and U.S. Navy. Minigun refers to a specific model of weapon that General Electric originally produced, but the term minigun has popularly come to refer to any externally powered rotary-style gun of rifle caliber. The term is sometimes used loosely to refer to guns of similar rates of fire and configuration regardless of power source and caliber. History. Background: electrically driven Gatling gun. The ancestor to the modern minigun was a hand-cranked mechanical device invented in the 1860s by Richard Jordan Gatling. Gatling later replaced the hand-cranked mechanism of a rifle-caliber Gatling gun with an electric motor, a relatively new invention at the time. Even after Gatling slowed down the mechanism, the new electric-powered Gatling gun had a theoretical rate of fire of 3,000 rounds per minute, roughly 3 times the rate of a typical modern, single-barreled machine gun. Gatling's electric-powered design received U.S. Patent No. 502,185 on July 25, 1893. Despite Gatling's improvements, the Gatling gun fell into disuse after cheaper, lighter weight, recoil and gas-operated machine guns were invented. Gatling himself went bankrupt for a period. During World War I, several German companies were working on externally powered guns for use in aircraft. Of those, the best known today is perhaps the Fokker-Lamberger, an externally powered 12-barrel rotary gun using the 7.92 x 57 mm Mauser round. It was claimed to be capable of firing over 7,000 rpm, but suffered from frequent cartridge case ruptures due to its nutcracker, rotary split breech design, which is fairly different from that of a Gatling. None of these German guns went into production during the war, although a competing Siemens prototype, possibly using a different action, which was tried on the Western Front, scored a victory in aerial combat. The British also experimented with this type of split breech during the 1950s, but they were also unsuccessful. Minigun, 1960s Vietnam. In the 1960s, the United States Armed Forces began exploring modern variants of the electric-powered, rotating barrel Gatling-style weapons for use in the Vietnam War. American forces in the Vietnam War, which used helicopters as one of the primary means of transporting soldiers and equipment through the dense jungle, found that the thin-skinned helicopters were very vulnerable to small arms fire and rocket-propelled grenade, RPG, attacks when they slowed down to land. Although helicopters had mounted single-barrel machine guns, using them to repel attackers hidden in the dense jungle foliage often led to barrels overheating or cartridge jams. In order to develop a weapon with a more reliable, higher rate of fire, General Electric designers scaled down the rotating barrel 20mm M61 Vulcan cannon for 7.62 x 51 mm NATO ammunition. The resulting weapon, designated M134 and known popularly as the minigun, could fire up to 6,000 rounds per minute without overheating. The gun has a variable i.e. selectable rate of fire specified to fire at rates of up to 6,000 rpm, with most applications set at rates between 3.000 to 4,000 rounds per minute. The minigun was mounted on Hughes 06 Kaius and Bell 058 Kiowa side pods, in the turret and on pylon pods of Bell A-1 Cobra attack helicopters, and on door, pylon, and pod mounts on Bell A-1 Iroquois transport helicopters. Several larger aircraft were outfitted with miniguns specifically for close air support, the Cessna A-37 Dragonfly with an internal gun and with pods on wing hardpoints, and the Douglas A-1 Skyraider, also with pods on wing hardpoints. Other famous gunship airplanes were the Douglas AC-47 Spooky, the Fairchild AC-119, and the Lockheed AC-130. Dillon Arrow Minigun. The U.S. government had procured some 10,000 miniguns during the Vietnam War. By 1975, production of spare parts had ceased with the Army in possession of a large inventory. By 1985, there were few spares left in the inventory. Units that received miniguns could not maintain them, so by the 1990s only Task Force 160, later named the 160th Special Operations Aviation Regiment, Airborne, or 160th SOAR, and some Navy special boat units kept them in regular use. Around 1995, the 160th SOAR began acquiring spare miniguns. Industry had a difficult time reproducing parts according to the original blueprints, so models that were being procured were mechanically unreliable and mixed with the inventory of working spares, resulting in using a mixed batch of working and unreliable weapons. This fact was unknown to the 160th SOAR, and the use of miniguns that would not work shook the unit's confidence in the system. The 160th was on the verge of dropping the minigun from its inventory entirely, which would essentially have ended its service life in the U.S. military. Around 1990, Dillon Arrow acquired a large number of miniguns and spares from a foreign user. The guns kept failing to shoot continuously, revealing that they were actually worn-out weapons. The company decided to fix the problems encountered, rather than simply putting the guns into storage. Fixing failure problems ended up improving the minigun's overall design. Dillon's efforts to improve the minigun reached the 160th SOAR, and Dillon was invited to Fort Campbell, Kentucky to demonstrate its products. A delinker, used to separate cartridges from ammunition belts and feed them into the gun housing, and other parts were tested on camels' ranges. The 160th SOAR liked the delinker's performance and began ordering them by 1997. This prompted Dillon to improve other design aspects including the bolt, housing, and barrel. Between 1997 and 2001, Dillon Arrow was producing 25-30 products a year. In 2001, it was working on a new bolt design that increased performance and service life. By 2002 virtually every component of the minigun had been improved, so Dillon began producing complete weapons with improved components. The guns were purchased quickly by the 160th SOAR as its standardized weapon system. The gun then went through the Army's formal procurement system approval process, and in 2003 the Dillon Arrow minigun was certified and designated M134D. The core of the M134D was a steel housing and rotor. To focus on weight reduction, a titanium housing and rotor were introduced, creating the M134DT, which had reduced weight from 62 pounds, 28 kilograms, to 41 pounds, 19 kilograms. The gun housing had a 500,000 round lifespan before it wore out, which was higher than a conventional machine gun's 40,000 round lifespan but was a reduced time for a rotary gun. A hybrid of the two weapons resulted in the M134DH, which had a steel housing and titanium rotor. It was cheaper with the steel component and only 1 pound, 0.45 kilograms, heavier than the M134DT, and increased its lifespan back to 1.5 million rounds. The M134DH is currently in use on various 160th Regiment platforms. Dillon also created specialized mounts and ammunition handling systems. Initially, mounts were only made for aviation systems. Then from 2003 to 2005, the Navy began mounting Dillon miniguns on specialized small boats. In 2005, the Naval Surface Warfare Center Crane Division procured guns to mount on Humvees. In Iraq, U.S. Army Special Forces units on the ground were frequently engaged by opposition forces, so they mounted M134D miniguns on their vehicles for additional firepower. After several engagements, the attackers seemed to avoid vehicles with miniguns. Later, the Special Forces units began concealing their weapons so opposition troops would not know they were facing the weapon. Regular Army units did the opposite, creating minigun mock-UPS out of painted PVC pipes tied together to resemble barrels to trick enemies into not attacking. Garwood Industries minigun. Garwood Industries created the M134G version with several modifications to the original GE system. The optimum rate of fire was determined by Garwood to be around 3,200 rounds per minute, RPM. The M134G is being produced with this firing rate as well as 4,000 RPM and the previous standard 3,000 RPM rate. Garwood Industries made several other modifications to the 1960s minigun design in order to meet modern-day military and ISO standards. This includes modifications to the drive motor, feeder, and barrel clutch assembly. Design and variants. The basic minigun is a 6-barrel, air-cooled, and electrically driven rotary machine gun. The electric drive rotates the weapon within its housing, with the rotating firing pin assembly and rotary chamber. The minigun's multi-barrel design helps prevent overheating, but also serves other functions. Multiple barrels allow for a greater capacity for a high firing rate, since the serial process of firing/extraction/loading is taking place in all barrels simultaneously. Thus, as one barrel fires, 2 others are in different stages of shell extraction and another 3 are being loaded. The minigun is composed of multiple closed-bolt rifle barrels arranged in a circular housing. The barrels are rotated by an external power source, usually electric, pneumatic, or hydraulic. Other rotating barrel cannons are powered by the gas pressure or recoil energy of fired cartridges. A gas-operated variant, designated XM133, was also developed. It is nearly identical but has barrels with ports that align with the piston drive in the center of the barrel cluster. It fired over 3,000 RPM but was not put into production. While the weapon can feed from linked ammunition, it requires a King feeder to strip the links as the rounds are introduced to the chambers. The original feeder unit was designated MAU 56/A, but has since been replaced by an improved MAU 201/A unit. The General Electric minigun is in use in several branches of the U.S. military, under a number of designations. The basic fixed armament version was given the designation M134 by the United States Army, while the same weapon was designated GAU 2/A, on a fixed mount, and GAU 17/A, flexible mount, by the United States Air Force, U.S. Air Force, and United States Navy, USN. The U.S. Air Force minigun variant has 3 versions, while the U.S. Army weapon appears to have incorporated several improvements without a change in designation. The M134D is an improved version of the M134 designed and manufactured by Dillon Aero, while Garwood Industries manufactures the M134G variant. Available sources show a relation between both M134 and GAU 2/A and M134 and GAU 2B/A. A separate variant, designated XM196, with an added ejection sprocket was developed specifically for the XM53 armament subsystem on the Lockheed AH-56 Cheyenne helicopter. Another variant was developed by the U.S. Air Force specifically for flexible installations, beginning primarily with the Bell A-1N twin Huey helicopter, as the GAU 17/A produced by General Dynamics. This version has a slotted flash hider. The primary end users of the GAU 17/A have been the USN and the United States Marine Corps, USMC, which mount the gun as defensive armament on a number of helicopters and surface ships. GAU 17/As from helicopters were rushed into service for ships on pintle mountings taken from Mk-16 20mm guns for anti-swarm protection in the Gulf ahead of the 2003 Iraq War. 59 systems were installed in 30 days. The GAU 17/A is designated Mk-44 in the machine gun series and is generally known as the Mk-44 when installed on British warships. The weapon is part of both the A/A49E11 armament system on the A-1N, and of the A/A49E13 armament subsystem on the U.S. Air Force Sikorsky HH-60H Pavehawk helicopter. The weapons on these systems feature a selectable fire rate of either 2,000 or 4,000 RPM. There is mention of a possible GAU 17 designation, GAU Shipboard Equipment 17, in reference to the system when mounted on surface ships, though this would not follow the official ASETS designation systems format. Gun pods and other aircraft mounts. One of the first applications of the weapon was in aircraft armament pods. These gun pods were used by a wide variety of fixed and rotary wing aircraft mainly during the Vietnam War, remaining in inventory for a period afterward. The standard pod, designated SUU-11/A by the Air Force and M18 by the U.S. Army, was a relatively simple unit, completely self-contained, with a 1,500 round magazine directly feeding delinked ammunition into the weapon. This means the minigun fitted to the pod does not require the standard MAU 56/A delinking feeder unit. A number of variations of this pod exist. Initially on fixed-wing gunships such as the Douglas AC-47 Spooky and Fairchild AC-119, the side-firing armament was fitted by combining SUU-11/A aircraft pods, often with their aerodynamic front fairings removed, with a locally fabricated mount. These pods were essentially unmodified, required no external power, and were linked to the aircraft's fire controls. The need for those pods for other missions led to the development and fielding of a purpose-built minigun module for gunship use, designated the MXU-470/A. These units first arrived in January 1967 with features such as an improved 2,000 round drum and electric feeder allowing simplified reloading in flight. The initial units were unreliable and were withdrawn almost immediately. By the end of the year, however, the difficulties had been worked out and the units were again being fitted to AC-47S, AC-119S, AC-130S, and even being proposed for lighter aircraft such as the Cessna O2 Skymaster. A fit of 2 MXU-470/As was also tested on the Fairchild O-23A Peacemaker, though the Royal Thai Air Force later elected to use another configuration with the M197 20mm cannon. In September 2013, Dillon Aero released the DGP-2300 gun pod for the M134DH. It contains 3,000 rounds, enough ammunition to fire the minigun for a full minute. The system is entirely self-contained, so it can be mounted on any aircraft that can handle the weight, rotational torque, and recoil force, 190 pounds, 86 kilograms, of the gun. The pod has its own battery which can be wired into the aircraft's electrical system to maintain a charge. Various iterations of the minigun have also been used in a number of armament subsystems for helicopters, with most of these subsystems being created by the United States. The first systems utilized the weapon in a forward-firing role for a variety of helicopters, some of the most prominent examples being the M21 armament subsystem for the A1 and the M27 for the O6. It also formed the primary turret-mounted armament for a number of members of the Bell A1 Cobra family. The weapon was also used as a pintle-mounted door gun on a wide variety of transport helicopters, a role it continues to serve in today. Users: Afghanistan, Australia, Austria, Brazil, Canada, Chile, Colombia, Croatia, Czech Republic, Egypt, France, Finland, Georgia, India, Indonesia, Iraq, Iran, Israel, Italy, Jordan, Malaysia, Mexico, Morocco, Netherlands, Norway, Pakistan, Paraguay, Peru, Philippines, Poland, South Korea, Saudi Arabia, Sierra Leone, Spain, French Polynesia, Thailand, Turkey, United Kingdom, United States. Fiction and popular culture. A distinctive invention of fiction is the handheld M134 minigun, a concept which was popularized by the 1980s to 90s films Predator and Terminator 2, Judgment Day, wielded by Jesse Ventura/Bill Duke and Arnold Schwarzenegger respectively, and decades later still appears in video games and films such as Captain America, The Winter Soldier, Grand Theft Auto V, and Furious 7, the latter where it is fired by Dwayne Johnson. For movie use, armorers slow down the M134 minigun's rate of fire to conserve ammo, and to allow the spinning barrels to be visible to the movie audience, with a hidden power cable for the firing scenes, and using blank ammo to ease recoil. Nonetheless, the prop is still extremely physically demanding, hence the actors wielding it were physically imposing and often had bodybuilding backgrounds. Generally, such depictions will totally ignore the weapon's need for external power, and sometimes even forget that it requires a source of ammunition. In practice, a man-portable M134 minigun would be nearly impossible to manage as an individual infantry weapon, and highly impractical for a human being to either carry or operate. A downscaled version of the M134, the XM214 microgun, never reached production status for such reasons. Machine gun, high rate, 7.62 mm, M134. Type rotary machine gun. Place of origin United States. Service history. In service 1963 present. Used by C users below. War in Afghanistan. Production history. Designer General Electric. Designed 1960. Manufacturer General Electric, Dillon Aero, Garwood Industries, Profense. Produced 1962 present. Variants see design and variants below. Specifications. Weight 85 pounds, 39 kilograms, 41 pounds, 19 kilograms, lightweight mod. Length 801.6 millimeters, 31.56 in. Barrel length 558.8 millimeters, 22.00 in. Cartridge 7.62 x 51 mm NATO. Caliber 7.62 mm, 0.308 in. Barrel 6. Action electrically driven rotary breech. Rate of fire variable, 2,0006,000 rpm. Muzzle velocity 2800 feet/s, 853 m/s. Maximum firing range 3280 feet, 1000 m, 1093 yd. Feed system cartridge on disintegrating link belt or linkless feed, dependent on installation. Sights dependent on installation, no fixed sights.
Please subscribe and thanks for watching.